to practice some example of curvilinear linear motions. Okay, last week we learned about determination of curvature of projectile motion. So this was we also determined how to find the centripetal accelerations. Okay, using the example of pendulum. Okay, so this is what we write. Okay, and then we also find out how to determine the Coriolis accelerations when you are subjected to radial chain. Okay, so after all, these are all vector plot of the direction chain. You may have to do the your own finding. Okay, but now today we're going to try out some example covering whichever. 那我们今天大概讲一下你这个课本讲义上的一些例题。So in the first example, okay, we're going to have this. So this was a handout given on the textbook. Okay, but be reminded that when you study and try to solve the problem, please don't read the question alone. So you have to plot the question into drawing. Okay. So this question is asking you, a box is sliding down a slope as described by the equation. Okay, so what you have to do is write out the equation. Okay, so you are by plotting. So you are given the slope. Okay, and there is a box sliding down. Okay, you need to visualize it. Okay, so how much is this slope? If this is the x-axis and this is the y-axis, this slope is 1/20 x squared. Okay, so this is the height of the slope. Okay, but it didn't tell you the direction of the slide down. But next step is telling you when it is sliding down. Okay, then you come down. Let's say to 5 meters. Okay. When y equal to 5 meters, no, it is telling you the x. So when you come down such that x is equal to 5 meters, okay, and x equal to 5 meters, what happened? You got the speed at that point. When you come down to this point, you got the speed. This is going to be a tangent to the slope. But here, it tells you something different. It tells you have the horizontal speed component, which is -3 meters per second. Okay? And then next, it also tells you you're going to have the horizontal acceleration, which is -1.5 meters per second. Okay? So this is what was given. And you are asked to find what is the velocity and acceleration in the vertical direction. You are asked to find Vy and Ay at x equal to 5 meters. Okay, if you are able to draw this, you are already halfway succeeding in solving. Okay， 所以那个你们解题最重要是要把题目读清楚，把这个文字可视化成图形。OK， 所以你这个题目基本上是一个箱子，从一个二次曲线的这个斜坡上，这个掉了下来，在第5米处 ，OK， 离谷底是0嘛，在第5米处 ，OK， 它的这个水平速度是-3米每秒，然后水平加速度是-1.5米每秒，它就是跟 x 反的方向，然后这个问题是找离 x 比 y，OK，so the question is okay, let's try solve that. Okay, what you see? Yeah. Yeah, in the plotting, you'll be able to find at different height, at different horizontal distance, then you're going to find the slope at different height. Okay. So how to do the solving? Okay, let's cover this. I need to page. Find this. Okay, I rewrite this. This is the given profile. Okay, you are asked to find, let's say, Vy. What is Vy? Okay, in this plot, you can see that the box will come down. Okay. So the speed definitely is along the tangent. Okay? But this tangential speed, okay, is going to be reduced into 2 parts. Okay? What are the 2 parts? First, you're going to have vertical component Vy. Second, you're going to have horizontal component Vx. But in the definition here, is it this is the x in the positive direction, and then this one, let's draw in different color. So this is the y in positive direction. So because the Vx is coming toward opposite direction, so you have the negative Vx, okay, and negative Ax, okay. So but this is how you construct this velocity triangle. Okay. Remember, velocity triangle. Okay, you're plotting tangential velocity into this Vy and Vx. Okay. The question is abstractions. Okay. Yeah, it gives you the y, the slope information. This is what we call slope information. Okay. From slope information, how do you find the Vy? Okay. Vy is Vy. Fair enough, huh? They are descending down. So before you get that, you are having a descending of the height divided by the chain of height. Okay? So then now you can do differentiations. But the question here is right hand side has nothing in terms of time. It is all in terms of horizontal position because this is a slope. Okay? How do you get from slope to velocity? Okay, then never mind. Even though I do know the slope, okay, I try to do the differentiation. Let's say you differentiate the thing with respect to x first before you finally differentiate the x dt。OK， 所以我们这个动作是做什么？右手边这个是 x 的函数，那我要对它做时间的微分，那我没办法直接对它做时间微分，我就对它做 x 微分，然后再乘上 dx dt. So this is what we call a chain rule, okay, in your calculus, okay. By substituting, what is this here? You have the x squared over 20 and differentiate with respect to the x, and then times dx dt. Okay, so this is what you have: 2 over 20 x times dx. Okay, so look at that. So this is now 110 the x times dx. If you're now doing the substitution of the value, then you have 110 times x at 5 meters times dx equal to minus 3. Then you have minus 15 over 10. This is minus 1.5 meters per second. Okay. So this is how you apply your calculus. 所以这个东西难是难在哪里？要用到你的微分，它不止还用到你的微分，你还要画。所以你当年如果读微分，只是把它当成一个步骤来读，那不好意思，后面你会被那个几何卡到，你没有把图画出来，你的微分配合向量，做要配搭得到才能得到正解。And then next, we are asked to find ay. How to find ay? Ay is what? Ay is actually the acceleration in the vertical direction. What you have to do is to differentiate the vertical speed with respect to time. Okay? And then next, we can proceed with that. But let's complete this. Even though question is asking you to find bx, but for you, we don't know what is your b. From the right angle triangle, you should know your b is equal to the square root of bx squared plus by squared. Okay, that is your minus 3 squared plus your this 2 minus 2/3 squared. So in the end, what you have? You have the 3 times square root of 5 over 4. Okay. No, is it 5 over 4? No. This is 3 all taken here. And some more for your information. Your speed, okay, is coming down with the slope. What is this slope? This is arctangent dy over dx. It is what? It is minus 1.5 divided by 3 arctangent. Okay? So we have arctangent 1 over 2. Okay, this is the angle of the slope. 所以为了完整性，你如果说要具体把这个图的这个方向画出来，或者那个图纸画出来，所以你就要做这个动作。This is the magnitude. Okay. And then this is the direction. So in this way you complete your philosophy. And then next, how about your ay? Your ay is differentiation of the vertical velocity. Then your vertical velocity has been obtained in this expression. Okay. So what you can write is the vertical velocity 1 over 10x and bx, and then you differentiate with respect to x, and then multiply with dx dt. Okay. 所以这动作是一定要的，为什么？ 这个动作，这个是因为你这个还是一样要 chain rule， 以上并不是时间的函数，所以你要做 chain rule。And then this one, after doing this, you have to do differentiations, okay? Would you like to do chain rule immediately? Let's see, we do it later, okay? Okay? If you do differentiations, then you straight away you have the dx dt 1/10 dx, okay? So this one no need to do chain rule because straight away you got the 1/10 x dot dx. What is x dot? X dot is your dx. So this term is your dx squared. Okay, and then next, the second part, this differentiate by parts. You have x over 10 and then dx dt. In this case, the second term is x over 10 and x. Okay. So with this, when you do the number substitutions, then you're going to obtain the speed. Okay, let's see here. Okay, so we have derived the dy, and then now ax, ay. So upon substitution of the number, then you got in this minus 2.15 into the second square. Okay, this is how it's solved. And then next we look at the example of the curvilinear motion in terms of the normal tangential component. Okay, so in this case, so let's stand up. Too tiny, the loading. Okay, a car is traveling along a road, and then it happens that the speed is related to the distance traveled along the circle. Okay. So it happens that the circle has a radius of 50 meters, so rho for radius, okay? And then next, you are asked to find what is the magnitude of the car's acceleration at the distance s is equal to 10 meters along the arc, okay? So I will do a quick one. So, yeah, you have this. In order to find the acceleration, remember accelerations along a circle in anti-component got two components. You could possibly have tangential acceleration, and you could possibly have the normal component of acceleration. Then there's a centrifugal acceleration. So then, what you have to do? To find the acceleration, you have to find what is the speed along the tangent line at distance s equal to 10 meters. And second, you then use the information above to find out the tangential and normal acceleration. Okay, so what is the first step to do? The first step to do is please draw out the please draw out the arc. Okay, let's see. Because this is a circular arc, so what we have to do is we have to draw them out. Okay, this is a circular arc, okay, and radius r equal to 50 meter. And then next, when you start moving, if this is a car or this is a boat, okay, they move up by a distance s equal to 10 meters. What is the direction of the car? So if you now do a quick one, you know the orientation, okay? This orientation is rho s or r theta is equal to s. Now your theta is equal to s over r. This is 10 meter divided by 50 meter. This is 0.2 radian. Okay? First we know the position. And then next, the funny thing here is you are given the velocity along the tangent line is proportional to 2 times the distance. Okay? Of course, the unit here is meter per second. Okay? So this is the given information. So will you be able to find what is the speed then at s equal to 10 meter? What is the tangential speed? The tangential speed is drawn like this. This is the tangential speed. Okay. Please make sure you are able to draw. Okay. And then next, again this is 2s. You are supposed to change. Again, do the substitutions. So this is 2 times the s is 10. Then you have the meter per second. 20 meter per second upon the substitution. And then next, because eventually you are asked to find the acceleration. Okay. Then there are 2 parts of acceleration you can have. Go down this. Okay. So now, for the same question, what is the acceleration? If you differentiate Vt again, then you're going to have At. The Vt dt is giving you the tangential acceleration. And at the same time, you're going to have normal acceleration. Normal acceleration is tangential speed squared divided by the radius. Okay? So before you do any solution, you already can find out the total acceleration. The total acceleration is the vector sum, okay, of the two. So this is your tangential accelerations. This is your normal acceleration. The vector sum, okay, will give you this. Okay. Remember our plot here. Before you do any solution, please get your direction ready. Okay? What is the magnitude of your A? The magnitude of the A is obtained by using your Pythagoras theorem. You have your ax squared plus ay squared. But in this case, because you're using the anti-coordinate, you're going to obtain this. What is the direction of your A? Your direction of the A is rotating off the x-axis up to this point. But for this point, you know the total angle is your theta plus 90 degrees plus, let's say this is a phi. Okay? This is the orientation of your acceleration. 所以加速度方向是什么？跟你刚才速度方向有一点类似。速度方向你很简单，基本上就是它是沿着切线。那你沿着切线你画出来的速度方向是 θ 角加90度，就是速度方向。那加速度方向呢是，它不是沿着切线加速度，它是切线加速度再加上法向加速度，所以你还要加上一个phi角。那phi角到时候怎么找？ How do you get your phi angle? The phi angle is obtained by arctangent of your AN divided by AT. OK， 所以老师现在的解法跟你们课本不大一样。OK， 为什么一定要用老师这个解法？老师这个解法是你的符号解。OK， 你符号解有一个好处是什么？我不需要知道数值，你还没解，你已经可以把关系找出来。然后你需要的是什么？我需要的是找到，我 AN 我知道吗？不知道。AT 我知道吗？不知道。现在这些关系都不知道，那我下一步就要去找，要反向。OK， don't do the way as your textbook example. Your textbook example is playing golf. You have memory of everything, but in reality you don't have memory of everything. In the step of solution, the first thing to ask is what is unknown. 所以你们在求解的过程中，第一步要问的是什么东西不知道。关系是你可以用一个符号解出来，然后再去列出什么东西不知道。Okay, the first thing we do is, let's say your AT, because we are given the S, we are given VT, so your AT is dVT dt. That is d to s dt. It is now 2 ds dt. That is 2 bt. Okay, in the meter per square. So that's the information. And then next, how do you find your vertical normal component? Your normal component, you remember what is the concept of normal component? Normal component is induced by the chain of direction. Okay? So this is the VT, AT direction. And then now, what is your VT? If your VT is moving from the bottom top, it does change in direction. So this is now your AN. Your AN is your VT square divided by the rho. 好，具体怎么带数字，你们就自己回去带。OK， 老师只把这个步骤讲出来，而且你每写一个公式，你要能够画出它的意义，那你才不会画错。OK， 啊 ，OK， 好，所以基本上就是这个部分我们就解答就到这里。OK， I'll show you the writing step. This example here, you are asked to find. So the working step is here. For the tangential part, you do the differentiations. Okay, then you got the tangential speed times dvt ds. This is 2 times 2s. In the end, you have 4s. 4s is equal to 40 meter, and s equal to 10 meter. And then next, what about the normal acceleration? Normal acceleration is your tangential speed divided by the radius is 8 meters per second, together with 40 meters per second square, then you obtain the total acceleration is equal to the square root of 40 square plus 8 square. Okay, I think this is wrong. Okay, then after all, the total solution is there. And also, you'll be able to find out what is the angle. Okay? 所以为什么要画图？画图是一次过给你最终答案。你如果按着步骤走，步骤去做，你的步骤很零碎，我哪里知道你下一步 ？OK？ 所以你解答一定要请你先画图。OK？ 往年的话，因为考试，比如说期中考，很多同学一股脑的就是拼命写公式。不好意思，你如果能直接画图 ，OK， 老师会给你至少50分。图都有的，公式都有 ，OK。然后那些只有写公式的同学，那你最终解如果对，那就给你满分。那不对，那你就看老师有没有眼花。还有，老师最不能帮你这个给你同评分的是，你如果给我一堆数字，啊，老师是没有办法给你同评分，因为我不知道数字的关系。OK， 你要做解答，最重要是把关系式、符号解先写出来，最后一步才是带数字。OK， 我们到这个年纪，你还只看数字吗？没有，你还是要把关系弄出来，关系式弄出来，最后才带数字解。Okay, a reminder on your this solution skill. Please make sure you write the relationship, the formula. 不要这么懒，这个公式是已经在你手上了，记得写一次。符号解，然后才带数字，这是什么？给人家看一下 ，OK？ 你是怎么求解 ？So this practice is eventually the same as a practice in professional engineer or building design. So even though today you have finite element analysis, but the professional engineer still do the working step. 所以你知道吗？你们现在的那个专业工程师要批准这个房屋设计合不合规格，人家还是一样，打开工程方式手册，一步一步求解。这是什么？你把这个步骤做完，那才有第二个工程师可以检查你的计算。你如果只有给我数字，没有给我公式，那我无从检查。所以在土木工程师认证的时候，有限元是不能用，为什么？我哪里知道你哪一步做错？但是你如果是把你的公式都写下来，每一步公式写下来， 那人家知道你是用循什么这个公式得到解答。Okay, then lastly we come to the example of this spinning ball. Okay, this spinning ball is different from the previous video on the turntable. 那我们来看一下之前的这个。Okay, Coriolis effect is something new to you, so you better go through it. The closest of that is this video. Let's see. So this is the turning of a ball on the turntable. Okay. 所以同学有没有看到？但是这个球跟我们题目不大一样，这是刚才那个球是自由在跑，它的移动方向是循什么？循着那个叫它的条件是在，就是它这么滚出来 ，OK， 它是没有一个滑轨 ，OK。然后这个丢球的，你再看一下。所以这个丢球又是一个极限，这个球是完全不接地面。OK。当球不完全不接触地面，它就直接做牛顿第一定律，这个维持同一个方向。所以这个球是，如果它虽然是抛线，但是你投影到表面的话，它是直线。So this projectile motion of the ball is in the vertical plane, but in the horizontal plane, it remains traveling in a straight line, even though the turntable is turning. Okay? If you observe from the ground, you see the ball is going the straight line along the horizontal plane. But however, if the observer point is mounted on the turntable, then you see the diffraction. This diffraction is what you call Coriolis acceleration. Okay. In this stationary one, this is a straight line, but in the rotating frame, this is deflected. Okay. Yeah, so with this background, okay, then we come to this question. What is this question? This question is different from the previous one. In the previous one, you have ball in the air, so they go through the straight line. In the second case, you have ball rolling on the turntable. Okay, then your friction could be very different. Okay, we might want to see the funny spinning ball. Then we'll come back to this later. Okay, anyway, for this one, because it's traveling along the guide, and good thing about this is every information is given. Okay? These two direction of the motion is independent. Let me draw them out. Okay, 我们第一个看转动台。So you are talking about turntable. In this case, the turntable will rotate about its axis. This is described by an angle theta. If this is currently x-axis, then x-axis will rotate, okay, with respect to the axis. So your angular speed is something. Okay? So in this case, theta is your 4 times time to the power of 3 over 2. Okay? 所以这是转动台的一个运动。OK？ 然后你可以去做微分。找到角度 ，you can now find the angular speed in terms of by differentiating the angular position. Then next, second differentiation will give you three times t to the power of minus half. OK， 所以这是转动台。OK， 然后接下来我们看，刚才我是讲 x 轴。x 轴转动，但是我们不方便说，所以我们在圆盘上你的这个盘，那我们一般不用 x， 这个盘我们用什么？我们用半径。The ball is starting from center, and then it's coming up. Okay, and what is the value? The value here is radius r. Okay, r is changing with time is 0.1 t cube. So your r dot is 0.3 t squared. Your r double dot is 0.6 t. Okay. So with this, now you found the relationship. Okay, but not to forget, this is changing with time. Okay, the direction of r is changing with time. This is your r1, this would be your r2. They are changing with time. Okay, so with this information, then how do you find the acceleration? Okay, and velocity. Okay, to find the velocity, let's do the quick one. Okay, to do so, I think you have to do the plotting. This is t, this is r, okay, and this is time t, okay? Okay, what happened at time equal to 0? At time equal to 0, let's see here. This is 4 t to the power of 3 over 2. This is 0.1 t cubed. Okay, this is what? This is your 0. If I now doing the plotting, this is your angles, 0 angle. This is your 45. This theta, this is 90. You can draw 30 degrees, you can draw the 60 degree. Okay. And then here is your radius. Okay, at 0, everything is 0. This is how you draw the polar coordinate. 0, first point. Then how about next point? At 1. What happened at 1? 4 0.1. 4 here is 4 radian. Yeah, it's quite a big turn. Okay, it's already going off. Then if you are not jumping too hard fast, then you put 0.5. So what's the value? And then you put 1. What's the value? Okay. And if you put 1.5, what's the value? So in order to help you doing this, you have to use your Excel. Let's have a quick solution. Okay, the reason why I have to go through this with you is because I want to make sure that you know the physical meaning. What's the theta? You go back and take your formula. See, this is your theta. This theta is 4t to the power of 3 over 2. This is your r is equal to y1 times t to the power of 3. Then this is your t. This is starting from 0. That's a 0.5. Okay, I can do the time stepping. Okay, and then what's the value here? This is 4 times e to the power of 3 over 2. This is the radius. This is 0.1 times e to the power of 3. Then with this, I can now do the calculations. So this is in terms of radian. I think the chain is too fast, so I'm going to make the step smaller. Why I say too fast? Because at 1 times 1 is already going 4 radian. What is 4 radian? 4 radian is 100 and more than 180 degrees. So this is all in terms of radian. So if you are not sure what is theta, let's change it to degree. This is radian divided by 3.14. This is pi and 180. So now let's see the angle. Okay. So this is telling you at 20 degrees, your position is only this my small value. And then at 60 degrees, then your value is increasing. In this way, then you're going to obtain the vector plot. Okay, so this is how we got the plot here. Okay, let me show you. Okay, I think did I get it right? Yeah. Yeah. So it's already turning a large value. So anyway, so the important thing here is, after you do the differentiation, please substitute the value to get the number. And then your tangential velocity consists of 2 parts. Okay, because now you have using the vector plot. Okay, what's the difference of polar coordinate? In case of polar coordinate, you have a tangential speed, always tangent to the trace. 所以你在用这个极坐标画图的时候，你的切线速度跟你极坐标的半径，它不是真正意义上的转动半径，它不是曲率半径，它这个单纯只是一个，你可以讲是一个一个发射台，一个跟踪站，它只是跟踪你的点，它不随你的这个曲线一直在动，所以这个叫 R，OK， 那 R 的话是你比较之前的 R1，就是 R2，你看到没有？所以这个就有这个半径的位。In the case when you trace along different angle on the marker, okay, your radius does change. Okay, and then as a result of this chain of positions, there is increase in the radius. But at the same time, remember, you have the angle chain. Okay, this is the theta. And then as a result, what is this ds? This ds is your rd theta. So if you are drawing this, then your velocity chain consists of two parts. The first part is the radial chain along the unit vector of radius. And then the second part is your ds. Your ds is rd theta. Okay, that is along the circumference direction. And then what is your total speed change? Your total speed change in magnitude is your Vr square plus the square root of r. This is your v theta square. What is your Vr? Your Vr, okay, this is dt, yeah? After differentiation, okay, you have your Vr, and this one is your v theta. V theta is not theta dot. V theta is the circumference velocity change. OK， 同学看到没？然后这个，所以通过这个方式，我们就可以找到解答。同样的，你如果加速度的部分 ，What is your acceleration? Your acceleration consists of two parts. One is along the radius direction. This is your increase in the radius. This is your centripetal acceleration. And then along the circumference direction, you have two parts. You have the r theta double dot plus the r dot theta dot. This is what you call your tangential acceleration per se. And then this one is your Coriolis. Okay. 然后一样的，你这个千万不要把它当成是你的 NT plot， 因为它这个单纯是一个观察站测你待测物的距离的变化 ，OK， 所以这是径向的加速度，然后这个是向心加速度，然后这个是切线方向的加速度，然后这个是科氏加速度。So in that way, after you get all the number, do the substitution in, then you should be able to get the answer. Okay, with this, then we are done for today, and then on the coming Thursday, we still will go through the lecture. Okay, there will be a lecture on your pulling motion and relative motion. Okay, with this we are done for today. Thank you.